Welcome back to part 2 of the quadratic formula. So you should have just finished the second try this problem, and I'm just going to give you a little hint if you got stuck towards the end. Inside of the square root, and this is just one part of the problem towards the end, but inside of the square root you should have gotten 1025, and at this point, again, you don't want to write your answer as decimals, but you do want to simplify what's inside the square root. So since it's ending in 25, you could check to see if it's divisible by 25. So that's 25 times 41. So that means that you can take out a 5 and you're left with the square root of 41 inside of the radical. And then once you get that, you also need to make sure that there's nothing that you can't divide by for both terms. So I don't want to do this exact one, but say you got 2 plus or minus 2 plus or minus 8 rad 2, and it was all over 2, then, or actually let's just go all over 4. You want to look at these terms, and this is the coefficient of the radical. You can't cancel anything out of the radical unless you were able to put it in front of it. But since these are all even, we can divide these terms by 2. So it's dividing by 2 over 2. And as a result, you would get 1 plus or minus 4 square root of 2 over 2. So hopefully that helps you if you're having trouble with the last part of number 2 to try this. Okay, and now we're going to look at what's called the discriminant. So in the quadratic formula, the expression under the radical or square root sign, the expression, and this is b squared minus 4ac is called the discriminant. So back up to the quadratic formula, this amount in here, whatever that is, b squared minus 4ac, that's called the discriminant. So the discriminant can actually be used to tell you how many solutions you're going to get. And we're going to look at the discriminant of a few examples. So the discriminant is b squared minus 4ac. So we're going to say a, b is 2, c is 5. So here, b squared, that would be 2 squared minus 4 times a times c. So that's 4 minus 20, which is negative 16. So at this point, if the number inside of the radical is negative 16, so think about, and this is not the discriminant is just the negative 16. But if you think about once you were to take the square root of negative 16, that's not possible. That's not going to be a real solution. So there's actually going to be 0 real solutions. And the graph, and we're not going to go much into the graphing because that's what we're going to do in chapter 2b to 3b. We're doing the solving in this chapter, and then we're going to go into the graphing in the next chapter. But that would be a quadratic, and it wouldn't cross the x-axis. So notice it's just going down to this point here, and it's not going any lower. Or it might be like this, but it's not crossing that x-axis. So there are no x-intercepts, which means that there are no solutions. Okay, this next one, we have a equal to 1, b is 10, c is 25. So b squared, that would be 10 squared, minus 4 times a times c. That's 100 minus 100, which is 0. So this was negative 16, so that's, if it's negative inside of the square root, then there's going to be no solutions. If inside the square root is equal to 0, so if we had whatever is in the quadratic formula, let's say we had negative b plus or minus, and then square root of 0 all over 2a. When you do plus or minus square root of 0, it's just going to be negative b over 2a. This just goes away. When you add or subtract 0, it doesn't change anything. So just because it's 0 in the square root doesn't mean that there's no solutions. It actually means that there's one solution. It's going to be, whatever that quadratic was, it's just going to be negative b over 2a. So for example, in this one, the solution would just be negative b, that's negative 10, over 2 times a, which is negative 5. That would be the solution. So there's actually one real solution, and the graph of this one would be, and this was not the exact graph of that one, but I am going to graph this one since we found the solution. So when x is -5 would be the solution. So that would be a quadratic going up, and the one point where it touches, that one point where it touches the x-axis would be the solution. So there's one x-intercept. So there's only one if it goes to that x-axis and then it turns around. And that's when inside of the square root, so the discriminant is 0. And then this last one, we've got a is equal to 2, b is -7, and c is +2. So b squared, that's -7 squared, minus 4 times a times c. So this is going to be 49 minus, and that's 16, equals 33. So this is positive. If you get a positive inside the square root, so whatever that first term is, -b plus or minus, and then you have a positive number in here, then we're going to end up getting two solutions. So for this one it would be negative b, so +7 plus or minus the square root of, and this would be +33 all over 2 times a. So we're going to get two solutions here. And I'm not going to go through and figure out what those exact solutions are, but in terms of the graph, it would look something like this. And we can see that it's crossing the x-axis 2 times. So there's 2 x-intercepts, which means that there are 2 real solutions. In this one, we had one solution because the discriminant was 0, and then here there were no places where it touched the x-intercept, and that's because the discriminant was negative. So number 3, it says state the value of the discriminant, and make sure you have it in standard form first, and then determine how many solutions there would be. So first we want it in standard form. That's 4x squared plus 5x plus 3 equals 0. So a is 4, b is 5, c is 3. So the discriminant is b squared minus 4ac. Again, if you've memorized the quadratic formula, or once you've memorized it, you'll remember it's just the part inside the radical. So that's 5 squared minus 4 times a, which is 4, times c, which is 3. So we have 25 minus, I'm going to write it down here, 25 minus 16 times 3, that's 48. So it's -23. So if inside the discriminant is negative, how many solutions are we going to get? So if it's negative, we did that up here, we have a negative number inside of it, then there's going to be no real solutions. And I mentioned this in the lesson yesterday on completing the square, but in tomorrow's lesson we're going to be going into imaginary numbers, and after that we'll go back to the quadratic formula next week and look at what the solution would be. So at this point we're saying there's no real solutions, but we're going to go back to that in a few days and go over what those solutions would actually be. So again, because it's negative inside the discriminant, there are no real solutions. Okay, number 4 says state the value of the discriminant. So again, we first want to put it into standard form. We know a is 1, b is 3, c is -10. So that's going to be b squared minus 4ac. We get 3 squared minus 4 times a is 1 times c is -10. And that's 9 plus 40, so 49. So number of solutions, because it's positive, we're going to get 2 real solutions. And we're not going to go through and finish that, but if we looked at -b plus or minus the square root of, so that would be 49 in there, all over 2, you could continue solving this. We know the square root of 49, that's just 7. So then you do negative 3 plus the square root of 49 over 2, and then minus. Okay, and then this last one, the third try this problem, it says solve the quadratic formula x squared minus 4x equals 12 using each of the methods below. So the first thing that you need to do is put it in standard form, and then what I would like for you to do is solve it by factoring, solve it by using the quadratic formula, and solve it by completing the square. So you should be able to do all 3 of those methods. Please go ahead and try that, and then make sure you do these on Schoology, and if you have trouble, you can always look at the key. So thanks for watching and listening, and I'll